And now we have mock test 2, where again we have even more questions that we'll be solving with you. When both of them are in the same direction, currents are in the same direction, constant speed means there's no acceleration, which means irrespective of the mass, length and the fundamental units, you should always remember the dimensions of force and energy. First I've replaced h with h dash because now the height it had to rise was just h dash, which is e square h. The relation between the horizontal range r of the projectile and the heights h1 and h2 are. We know the moment of inertia about a perpendicular axis through the center of the loop. The quantity of heat rejected by the gas during the process CA. So in the isobaric process, I want what is the energy loss. What is minimum common frequency with which three parts can vibrate. 25 ohm in series with this, which means the equivalent resistance of this entire part is 75 ohm. Hi students, welcome to this session here at Infinity Learn by Sri Chaitanya. I'm Aniruddha, your physics teacher. And today we are looking at mock test 2. Now this is the series that's going on. Earlier day we had mock test 1, where we discussed a set of questions that are very important for your JEE that's coming up just in a few days, not even a month left. And now we have mock test 2, where again we have even more questions that we'll be solving with you. So stay with me throughout and we'll be going through it. The first question says that two long parallel wires carry currents I1 and I2 such that I1 is greater than I2. When the currents are in the same direction, magnetic field at a point midway between the wires is, this is 6 into 10 to the power minus 6, 6 into 10 to the power minus 6 Tesla. And if the direction of I2 is reversed, then it becomes 3 into 10 to the power minus 5 Tesla. 3 into 10 to the power minus 5 Tesla, then the ratio of I1 to I2 is. There's some typing mistakes here, but you get the idea of the question. So let's draw this out. You have one I1 and one I2, both carrying current. Let's say in the beginning they're carrying current in the same direction, I1 and I2. And you want the magnetic field at the midpoint. Let's assume the distance is d from each one. It's midway, so it's equal distance from equal distance from both wires. So B1 is equal to mu naught I1 divided by 2 pi d. That's the formula of magnetic field at a distance from a straight conductor. And B2, the magnetic field because of wire 2 is mu naught I2 divided by 2 pi d. Right? Now originally here it says that when both of them are in the same direction, currents are in the same direction, magnetic field at a point is midway between them, and that field value is 6 into 10 to the power minus 6. In the second case, if one of them is reversed, it is 3 into 10 to the power minus 5. Now even though it says in the same direction, we know that in the same direction, the magnetic fields are actually cancelling each other out. So the magnetic field because of I1 and that because of I2 are cancelling each other out. So the net magnetic field is going to be B1 minus B2. So if I do B1 minus B2, let's do it B same is equal to B1 minus B2, and that is equal to mu naught by 2 pi d into I1 minus I2. In the second case, when they are moving opposite to each other, then in that case magnetic fields are supporting each other, because suppose if I2 is reversed, then the magnetic field because of this goes into the page, because of that also goes into the page. So there you have B1 plus B2, which makes it mu naught, let's leave the I for now, 2 pi d I1 plus I2. Now I1 value is BS value is given to us, and B opposite value is also given to us. So let's remove all of this, let's do it over here. So BS by BO is equal to, your mu naught by 2 pi d's will cancel out. You would be having I1 minus I2 divided by I1 plus I2. So right off the bat, if we do BS was what? Same direction was 6 into 10 to the power minus 6. So 6 into 10 to the power minus 6 divided by, here you have 3 into 10 to the power minus 5. right? Or I can write it as 30 into 10 to the power minus 6. That is equal to I1 minus I2 divided by I1 plus I2. Now 10 to the power minus 6 cancels out. That is why I wrote it in that form. This gives me 5. So 1 by 5 is equal to I1 minus I2 divided by I1 plus I2. Now I keep telling students, don't cross multiply and calculate. Instead, look at the options. Your correct option right off the bat, I can see it would be given by I1 by I2 would be equal to 3 by 2. It would be 3 by 2. Why? Because if I1 is 3 and I2 is 2, then 3 minus 2 is 1. You have 1 in the numerator, and 3 plus 2 is 5, you have 5 in the denominator. So just by comparing, it's much faster to do it. So correct option is option D. Let's look at the next one now. This says two blocks are connected over a massless pulley as shown in figure. The mass of block A is 10 kg. This is 10 kg. Coefficient of kinetic friction is 0.2. Block A slides down the incline at constant speed. Constant speed means there's no acceleration, which means the forces on this are MA G sine theta. Only the sine component acts in this direction. In the backward direction, you have tension. Here also you have tension, and that tension value is equal to your MB G. Right? Because again, the forces are equal because there's no acceleration. So we know the tension value, and I also know that there is going to be a kinetic friction in this direction because it's sliding down. So the kinetic friction Fk would be equal to mu k into Ma G cos theta. Because the cos theta component was perpendicular, the normal reaction would have been MAG cos theta multiplied with the coefficient of friction. So we equate this part. We equate for the forces on point A. If we do that, we'll get MAG sine theta is equal to T is just, we can replace it with directly MBG plus mu k MAG cos theta. Okay, this is capital A, MAG cos theta. Now what all values have we been provided? We have been given theta, MA and mu k. We need to find MB. So first up, cancel out the G's. Cancel out the G's. You have MA is equal to 10 into sine of 30 is half. MB is what we need to find out. Over here, mu k is 0.2. Multiplied with again another MA, that is 10 into cos theta is root 3 by 2. Cancel it out with 5 over here. 5 into 0.2 goes with 1. 5 into 0.2 is 1. So MB, this again is 5. MB would be equal to 5 minus root 3. Because this root 3 comes over this side. Do we have an option? Okay, we have it in decimals. So root 3 is 1.73. So it's essentially 5 minus 1.73. So that you can tell is going to be 3.3, roughly around 3.3. Okay, because 5 minus 1.7 takes it to 3.3. So that's it. That's our correct option. Moving on to the next one now. The next question here says that E, M, J and G denote energy, mass, angular momentum and gravitational constant respectively. The dimensions of Ej square by m to the power 5 G square are that of, we need to find essentially dimensional analysis. Now I have told in multiple sessions that I have done that irrespective of the mass, length and the fundamental units, you should always remember the dimensions of force and energy, because everything else can be easily derived from them. So first up we have energy. What do we know as the dimensions of energy? Let's put it out here. The dimensions of energy, E is equal to ml2 T minus 2, right? Next thing is mass, M, and M is just regular, it's a fundamental quantity, so M is just M. Then is J is the angular momentum. Now, how do I get to the angular momentum? The angular momentum J is equal to mvr. So that dimensionally would be equal to, M will give the mass M, the velocity is Lt minus 1, and the distance R over here, the radius over here gives another L. So your J becomes equal to ml2 T minus 1. ml2 T minus 1. Next quantity, let's put that in here, J equal to mL2 T minus 1. After J, we have the gravitational constant. So for gravitational constant, we'll use G is equal to Fr square divided by M1 M2. Comes straight from Newton's law of gravitation. F is equal to Gm1 M2 by R square. So let's put it in. For F, you have ml T minus 2, that is the dimensions of force, into R square means another L square, divided by, we have m2, m square, because there is mass into mass. So that gives me m to the power minus 1, L into L square is L cube, and T to the power minus 2. So our dimensions for G are m minus 1 L cube into T to the power minus 2. Now you may remember this. You'll say it gets a little faster if you remember. Yes, it will get faster if you remember, but it's near impossible to remember the dimensions of every quantity that you study. So my suggestion is, in case you don't remember energy and force, everything else is not too far away. Now that we've got the dimensions for everything, we need to calculate the dimensions of this. So the dimensions of this are simple. We have Ej square divided by m to the power 5 G square. So E is ml2 T minus 2. Let's put that in. ml2 T minus 2. Next up we have J square. So J was given by this. When you square it, m becomes m square. L to the power 4 and T to the power minus 2 because it's squared. Divided by, we have m to the power 5. That's fine with us because m was as is, m to the power 5. Multiplied with G square. So you square this again, you get m to the power minus 2, L to the power 6 into T to the power minus 4. Right? Now let's see what the dimensions of this are when we simplify all the masses and lengths and times. Here up top we have m cube. Down below we have m to the power 5 into n to the power minus 2. So here also we have m cube. So the masses actually cancel out. Next, let's look at the length. We have L square into L to the power 4. So L to the power 6 up top. Down below also we have L to the power 6. So even the lengths cancel out. And what about the time? We have T to the power minus 2, T to the power minus 2, which is T to the power minus 4. Here also T to the power minus 4. So even the times cancel out, and our dimensions for this is just m to the power 0, L to the power 0, T to the power 0, which means this is a dimensionless quantity. Now we have to compare the dimensions of this with one of them. Which one is a dimensionless quantity here? It is angle, because it's the arc length divided by the radius, length by length. Okay, so that is our correct answer. Next up, in a given circuit with steady current, potential drop across the capacitor must be. So I need this, I need the VC over here. Now it's a steady current, which means in steady current, this capacitor does not allow any current to flow in this. So when you're finding for the current, the magnitude of current, you can ignore that this wire even exists. Just think this has been cut off. And this is just the circuit through which current is flowing. So what is the current flowing? I would be equal to 2V minus V, because if this is one circuit, then 2V and V are in opposite directions. So the resultant EMF is just going to be 2V minus V. So that is just V divided by, you have again R and 2R in series, which means you have 3R as the resistance. So 3R. I is given by V by 3R. Now I want what the potential of A and B are. So I can do along this line, the potential VAB would be equal to 2V minus I into 2R. Okay, because 2V is the potential it tries to create, but there's a potential drop of 2R over here. So we have 2V minus I into 2R. So that gives me 2V minus I into, so I is this. So that will be 2V by 3. 2V minus 2V by 3 gives me 4V by 3. Right? Did I do that correct? 6V? 4V by 3. So that is VAB. That is the potential about these 2 points. Now that is also the potential about these two. And in order for this part over here to cut off the current, the potential that these two create should be equal to VAB, which means VAB should be equal to V plus VC. Now V is already given here, VAB we have calculated. So if you put that in, 4V by 3 minus V is equal to VC. So VC is V by 3. 4V by 3 minus V is just V by 3. So the potential drop across the capacitor is V by 3. Okay. Next up, a glass marble dropped from a certain height above the horizontal surface reaches the surface in time t and then continues to bounce up and down. The time in which the marble finally comes to rest is. So what do we know as the relation for the time taken to fall a certain height? We know the time relation is given by t is equal to root over of 2h divided by g, where h is the height from which you drop. So now the total time t net is equal to root over of, originally this is the first time, this is you let the ball drop, it drops down, so that is the time needed. So it is root over of 2h by g plus, now it bounces up. When it bounces up, because of its coefficient of restitution, which is, since we see the E factor here, I know that's the coefficient of restitution. So we know that when it bounces up, when you leave it from a height, it goes down. When it bounces up, if the coefficient of restitution is E, then the height to which it will bounce is given by h dash is equal to E square into h. Okay, we know this for a relation. If you don't know the relation, you can even derive it out. E is just V by U. E is V by U, then just compare and you'll get this relation. So this is the height to which it will rise. So the next time, so when it rises up and again falls down after the bounce, where the height is given by h dash, then the time taken is 2 into root over of 2e square h divided by g. Now there's two things. First, I've replaced h with h dash because now the height it had to rise was just h dash, which is e square h. Next, but the other thing is that I've put a 2 over here because in the first case it was just falling down. This includes the time of going up and again coming down. So it's 2 times the time of falling down. So that is why we have the factor of 2. The next bounce that it does, it would have 2 into root over of 2e to the power 4h divided by g. Why? Because e square h was h dash, so h double dash is going to be e square of h dash, which is equal to e to the power 4 of h. So each bounce ensures that there is an extra factor of e square coming in there. So if I just simplify this a little bit, then I would get you have this continuing on. If I just simplify this, I get t net is equal to root over of 2h by g. I can take that common out. I have 1 plus 2 into 1 plus 2e. I can get an e out because if I take this e square out, this comes off as e. Here also it comes as e square. So if I take 2e common, I will essentially be having 1 plus e square plus e cube plus so on, all the way till infinity. Okay, just look at this relation, and here if you have any difficulty, then try to break it down into steps. Get the e square out as e, get the e to the power 4 out as e square, and so on, and you will see that this reduces to this form. Now over here we have this entire setup, which is an infinite series where the common ratio, where the ratio is just e, and that is less than 1. E value is less than 1. So I know the sum till infinity of such a series, it's given by, let's write the other part first, 2h by g into 1 plus 2e into 1 divided by 1 minus e, because e is less than 1. So this is the sum till infinity for this part. Now over here, I think we can simplify stuff a bit. we get root over of, so this 2h by g is the original time t, because that's the time it takes, the original time t. So this is equal to t into, here if I multiply, I have 1 plus e, remember this 2e is multiplied to this thing, so 1 plus 1 minus e, 1 minus e plus 2e divided by 1 minus e. So this would just go, this 2e plus 2e would just give you plus e. Minus e plus 2e is 1 plus e by 1 minus e into t. So correct option is option C. Okay. I know this might seem like a difficult question, but once you understand the breakdown of the question, it's pretty simple. Okay, you have to understand the breakdown, that this is the drop, and most students will miss out on this time, or they would miss out on this 2 over here. So be very mindful about what the process is that's happening. Okay. Next up, it says a thin wire of length L and uniform linear mass density R is bent into a circular loop with center O as shown. The moment of inertia of the loop about the axis x-axis. So over here, we know the moment of inertia about a perpendicular axis through the center of the loop. It's given by mr square. Okay. So in mr square, we have not been given the radius r. We have been said the linear mass density rho. I'm assuming this is going to be rho. This is going to be rho. We don't know the radius yet. We just know the length and the linear mass density. So what is the total mass? The total mass m is equal to rho into L. Okay. Now as soon as I bend it into a circle, a length L, if I bend it into a circle, what is the radius going to be? I know that 2 pi r, the circumference of that circle, should be equal to the total length L. So r is equal to L by 2 pi. Now let's find the moment of inertia about the axis passing through the center. It's given by I, let's call it Iz, because it's a perpendicular axis. So Iz is equal to mr square. M is equal to rho L into r square. R square is L square by 2 pi. L square by 2 pi. So that makes it rho L cube divided by 2 pi. Rho L cube by 2 pi. Now I want, before I can move here, I first need the moment of inertia about this axis. For that, I'll use perpendicular axis theorem. By perpendicular axis theorem, I know this Iz is equal to Ix plus Iy. So Ix and Iy would be equal because it's symmetrical in both axes. So Ix is equal to half of this, that is rho L cube divided by 4 pi. Now I have got about this axis. Now I can use the parallel axis theorem, which essentially means that my Ix dash would be equal to Ix plus mr square, right? Mr square. So Ix was rho L cube divided by 4 pi plus mr square was just, this itself was my mr square over there, so I can put that in, equal to plus rho L cube divided by 2 pi over there, right? My bad, I've made a slight mistake. This would be 4 pi square. This all would be 4 pi square because I was doing L by 2 pi whole square. So that means over here I would be getting 8 pi square. Half of that would be 8 pi square. So here I have 8 pi square, and over here I will be having L cube by 4 pi square. That makes this as rho L cube into rho L cube by, I can take the 4 pi square common, 4 pi square. So half plus 1, that is 3 by 2 into 3 by 2. This would be half plus 1, 3 by 2. So that is 3 by 8 pi square. Do we have anything? Rho L cube divided by 8 pi square. So this is our correct option. Okay. Let's move on to the next question now. This one says that a stone projected with a velocity u at an angle theta with the horizontal reaches the maximum height h1 when it is projected with a velocity u at an angle pi by 2 minus theta with the horizontal, it reaches maximum height h2. The relation between the horizontal range r of the projectile and the heights h1 and h2 are. So let's write it out. h1 is equal to u square sine square theta divided by g, right? U square sine square theta divided by 2g over here, my bad. It's u square sine square theta divided by 2g. And next up you have h2, and h2 would be equal to u square cos square theta divided by 2g. How do I know that? Because u square sine of pi by 2 minus theta, sine of pi by 2 minus theta is cos theta. So that is why you have cos square theta divided by 2g. So we have h1 and h2. What else do we know about the range? Range relation is given by r is equal to u square into sine 2 theta g, right? Sine 2 theta, so which we write as 2 sine theta cos theta, 2 sine theta cos theta divided by g over here. Now I have to relate h1, h2 with r. So let's try it out. Best thing is to look at these and to look over here. Because once you do that, you will see that r square, if I do r square becomes equal to u to the power u to the power 4 into 4 sine square theta cos square theta divided by, we have g square over here, divided by g square. Now over here let's multiply 4 in the denominator and numerator. So I keep a 4 here and I multiply a 4 here. Why do I do that? Because now if you look, if I write it in this form, this 4 into 4 I take it out and keep as 16 outside, and this u to the power 4 sine square theta cos square theta by 4g square can be written as u square sine square theta by 2g into u square cos square theta divided by 2g. Okay, so this is your h1, the second part is your h2. So r square is equal to 16 h1 h2. So root over of this is going to give you 4 root over h1 h2. Okay, you can go by a different process also, going, checking each one and so on. That's a long process. This recognizing that from here I go to represent this in some form where it's a multiple of that requires practice. So if you keep on practicing, these questions will click in your mind in the examination hall, and then you can do these questions much faster. Next question, carbon monoxide is carried around a closed cycle ABC in which BC is an isothermal process as shown. So this is the isothermal process. Gas absorbs 7000 joule of heat as its temperature increases from 300 to 1000 Kelvin and going from A to B. So in this is the isochoric process where there is no change in volume. The quantity of heat rejected by the gas during the process CA. So in the isobaric process, I want what is the energy lost. So first up, here in this isochoric process, the energy that is being absorbed is 7000 joule. Since I know that this is an isochoric process, work done will be 0. So dq, the dq would be equal to du. So the change in internal energy would be the entire 7000 joule. Now this du is NCV dt, and that is 7000. CV, because it's more carbon monoxide, it's a diatomic gas, so CV is 5 by 2. So N into 5 by 2R into what is the change in temperature from A to B? Because it's an isothermal process, I know over here it is going from 300 to 700. So in that case, it's just 700. Difference delta T is 700. That is equal to 7000. So remove this, gives you 10 over here. You can even cut this out, leaving a 2. So your N is equal to 4 by R. I needed this number of moles because without that, I will not be able to find the work done in the second part of the process. Now, in this part over here, we need to find the work done. Remember, over here, change in internal energy is 0. I don't even need to bother about it. Here, I've seen the change in internal energy is 7,000 joule. I need the change in internal energy over here because it's a cyclic process. I know in the complete cycle, when it starts, maybe it starts here. Maybe, okay, let's have it starting here. It starts here, goes up. When it comes back, since it's come back to the same state, the change in internal energy should be 0. Which means DUAB plus DUBC plus DUCA should be equal to 0. Now DUAB we already know is given by 7,000 joules. DUBC we know is equal to 0. Okay, we know DUBC is equal to 0. So DUCA we can calculate. DUCA is equal to 0. So DUCA is equal to minus 7,000 joules. Now remember, this is not the answer. This is the change in internal energy from C to A. Over here, this is not the energy that is absorbed or released because there's also work done here. There's a change in volume. So we have du is given by this. With regards to this, what is the work done? Let's write it directly. Let's solve it directly in the first law equation. So dq is equal to du plus dw. In place of dw, we do it as pdv. pdv is just nr dt because pv is equal to nRT. So dq is equal to du, that is 7,000. It's minus 7,000 actually, plus pdv is nRT. N value we got as 4 by r, n into r into dt. T is, it's going from 1000 to 300. So it's decreasing by minus 700. So r cancels, your 4 into 700, that gives you minus 2800. Minus 7000 minus 2800 gives you minus 9800. Minus because it's the energy that is rejected, it's released by the gas. Okay, so again there were quite a few steps to this, but it's like you proceed down the path that seems right to you. If you get stuck, see what variable you need, go to the other path to get that variable, and that is how you keep on proceeding. Okay, next up, an asteroid of mass m is approaching Earth initially at a distance of 10 RE with speed v1. It hits the Earth with the speed vf. Then we need to find what is happening over here. So it's just conservation of mechanical energy. At the furthest point, your total energy is going to be half mvi square plus you have minus gmem divided by 10 RE. And when it has come close on the surface of the Earth, then the energy should be equal. So this should be equal to half mvf square plus minus of gmem divided by just RE, because now it's at the radius of the Earth. Okay, so over here you can just shift terms since I'm finding for vf square. Vf square is going to be, you can first cancel out the masses, out. So your half Vf square would be equal to half Vi square plus Gmre into 1 minus 1 by 10. So if you want to remove the halves, just remove this and multiply a 2 up top. So your Vf square is Vi square plus 2 Gm by Re to 1 minus 1 by 10. Do we have an option here? Me by Re into 1 minus 1 by 10. I think it's option 1. No. There's a M up top. It's option C. Yes, it's option C, because Vi square plus 2 GME by Re into 1 minus 1 by 10. Okay, it's simple, it's basic conservation of mechanical energy. Next question says, let there be a spherically symmetric charge distribution with charge density varying as rho r is equal to rho naught, 5 by 4 minus small r by capital R up to small r is equal to capital R, and rho r is equal to 0. Then small r is greater than capital R, where r is a distance. The electric field at a distance, this would be r, I'm assuming, this would be r, from the origin is given by. So over here, first step we need to do is find the enclosed charge in any random radius, small r. In a radius small r, what is the enclosed charge? So we know charge enclosed would be given by Q enclosed being by integration rho dV, rho r dV. Now this dV, since it's a symmetrically distributed charge, this dV can be written as 4 pi r square dr. So we have rho r, let's put that in, rho naught into 5 by 4 minus small r by capital R into 4 pi r square dr. This is dr. This is dV, 4 pi r square dr. Okay, let's make this a bit neat, because this can be a bit confusing otherwise, to 4 pi r square dr. So now we have to integrate this. When we integrate, what do I get? I can take rho naught and 4 pi out. Denominator, I can't take anything out yet. Inside, when I integrate, I have 5 by 4 r square, that is going to give me 5 r cube divided by 12, because r cube by 3 into 4 would be 12, minus r into r square would make it r to the power 4, so you would have r to the power 4 divided by 4r. That's it. That is your enclosed charge, right? Can I take a few things common here? I can take a 4 out, I'm assuming. So remove this 4, keep a 3 remaining, and I can get a 4 out over here. Now this is my enclosed charge. Now I can proceed into the Gauss law. In Gauss law, what do I know? I know that E into E dot dA, since I'm taking a spherically symmetric charge distribution, the area would be 4 pi r square for the sphere, and that is equal to this enclosed charge divided by epsilon naught. So rho naught 4 pi by 4 epsilon naught into 5 by 3 r cube minus r to the power 4 divided by capital R. Okay. Now this 4 pi and 4 pi can cancel out. I can take them out right away. This r square can take away this cube here, leaving an r in this case and an r to the power 2 over here. I can take one r common, so that I have E is equal to rho naught r divided by 4 epsilon naught. So I've taken there was one r remaining and r square remaining. I took one r common, so that leaves behind 5 by 3 minus only 1 r remains, small r by capital R. So we have an option here, rho r by 4 epsilon naught 5 by 3 small r by capital R. This is our correct option. Okay. Most students would, as soon as they get here, they'll get confused, because this part looks very similar to this, but here it's 5 by 4, it's 5 by 3. Maybe I made some calculation mistakes, and they'll mark one of these. But have faith in yourself and mark the correct option. Whatever you have done is generally correct. Okay. Don't lose hope. Don't fall into the trap of the examiner. Here it says Young's modulus of a wire of length L and radius R is y per meter square. If the length and radius are reduced to L by 2 and R by 2, then its Young's modulus will be basic theory based question. It would remain y, because Young's modulus does not depend on the dimensions of whatever you are measuring over there. It only depends on the material of the wire. As long as the material is same, Young's modulus remains the same. Next, in a CE transistor amplifier, the audio signal voltage across the collector resistance with collector resistance 2 kilo ohm is 2 volts. If base resistance is 1 kilo ohm, the current amplification of transistor is 100. What is the input signal voltage? So first up, let's find out what is the collector current. The collector current IC is equal to the collector emitter voltage divided by the collector resistance. Okay, so that is 2 divided by 2 kilo ohms, that is equal to 1 milliampere. This is the collector current. Next thing you need is the base resistance. Next thing you need is the current amplification. So this over here, beta is equal to IC by IB. And over there, IC beta value is given as 100. So your IB is equal to IC by 100. So 1 milliampere divided by 100, that makes it 0.01 milliampere. That is your base current. Now, since you want the input signal voltage, VEB is just going to be IB into RB. So base current we have found 0.01 milliampere multiplied with what is the resistance of the base? Resistance of the base is 1 kilo ohm. So it's 10 to the power 1 into 10 to the power 3. So that is going to give you over here, this is in milliamperes, right? This is in milliamperes. So over here we had another 10 to the power minus 3 as well, because it was milliampere. These two cancel out. You have 0.01 amperes, that is, this would be volts. We are measuring the voltage. 0.01 volts, that is 10 millivolts. Okay. Next question. Hydrogen atom in its ground state is excited by a monochromatic radiation of lambda is equal to 16 by 15 R, where R is the Rydberg's constant. The number of spectral lines in the resulting spectrum emitted will be. So over here we use the Rydberg's relation, which says that 1 by lambda is equal to R into 1 by N1 square minus 1 by N2 square. Now, since it's jumping from the ground state of hydrogen, I know N1 is equal to 1, and this N2 is what I need to find out. Okay, so over here lambda, if you put, it's 16 by 15 R, so you'd effectively be having 15 R by 16 is equal to R into 1 minus 1 by N2 square. So cancel out the R's. You have 15 by 16 is equal to 1 by N2 square. N2 value would come as 4, because if you have 4 square, you have 16 here. 1 minus 1 by 16 is 15 by 16, right? So N2 value is going to be 4. N2 is equal to 4. Now, what does this tell you? This tells you that the wavelength that you supply, that is able to excite it, the maximum level that it can excite that electron is to n is equal to 4. Now from n equal to 4, when it comes down, how many spectral lines? So it can jump from n equal to 4 to n equal to 3, from 3 to 2, from 2 to 1. Also it can go from 4 to 2, it can go from 3 to 1. There are many possible combinations. So there's 1, 2, 3, 4, 4 numbers, and it can take any possible combination between the two. So that is why over here, if this is n, then the total number of spectral lines is going to be NC2. Lines is going to be NC2. The combination of these 4 levels, it jumped from any one to any one. So there's going to be that combination here. So that you can know is just going to be n into n minus 1 divided by 2. So that is 4 into 4 minus 1 is 3 divided by 2. That is equal to 6. So the answer is, there would be 6 spectral lines emitted over here. Okay. Next question, it says 2 communicating vessels contain mercury. The diameter of one vessel is n times larger than the diameter of the other. Column of water of height h is poured into the left vessel. The mercury level will rise in the right hand vessel by a certain relation. So over here, what do I know? Let's assume that the levels have gone down by, This was the original level, right? Actually, this will go down deeper. So let's keep things a bit more realistic with our marking. Over here, this thinner one will go down more than the taller one. So let's assume that this went down by x and this rose up by y. then the net difference between them, net difference in level here is x plus y. So the weight of this water is equal to the weight of x plus y height of mercury over here, because by Pascal's law, at this level, at the level where the mercury starts in this side, at that level the pressure should be the same. So I know pressure of water is given by H rho G, rho value is 1, H into G, and that is equal to x plus y into your density is provided as S. So x plus y into S, right? So what do we need to find out? We need to find out, so x plus y is equal to Hg divided by S. Now I can't be done here. I need another relation between x and y. What relation do I have between x and y? I know that the volume that decreased over here has to be equal to the volume that increased over here, because the amount of mercury should remain the same. So in this part, the volume that the mercury went down by over here should be equal to the volume that the mercury went up by over here. That is why over here it went up less, because the area is more. So let's say a diameter of one is n times the diameter of the others. Forget diameter, let's consider it as radius, won't even make a difference. So what do I know? I know that pi into d square into x over here is equal to pi into its n times, so n square d square into y, right? Because over here x d square into x, so this y level is going to be less, because on the y side the diameter is n times. Cancel out the pi d square, you have x is equal to n square y. Now this y is what I need to find out, how much did the mercury level rise by. So if you put that in here, you get n square y, right? So y into 1 plus n square is equal to Hg by S. So y is equal to Hg by S into 1 plus n square. So do we have an option? Hg by, oh my bad, this g also will not stay. This g also will not stay. That is because there should have been also x plus y into g, x plus y into s into g on this side. The g would have cancelled out. So remove the g's. The g would not stay. You just have h by s into 1 plus n square, h by s into 1 plus n square, option B. The next question says that when a metallic surface is illuminated by a light of wavelength lambda, the stopping potential for the photoelectric current is 3 volts. When the same surface is illuminated by a light of wavelength 2 lambda, stopping potential is 1 volt. We need the threshold wavelength for the surface. So what is the first equation in the first case? In first case it is 3 volts. So essentially 3 electron volts is equal to Hc by lambda. Lambda is the wavelength that you supply, divided by Hc by lambda naught, where lambda naught is your threshold wavelength. In the second case, it is just 1 volt, so it is just 1 eV. So 1 eV is again equal to Hc, but the given wavelength now is 2 lambda. It's 2 lambda over here, and minus over here you have the same stopping threshold wavelength over there, not the stopping potential, the threshold wavelength as Hc by lambda naught. Now over here, the one thing you can do is, in place of 1 eV, you can replace this entire thing over this side and then calculate. You can do that, or you can just compare. You see the values and you put in the values and see what can give you the result for this as 3 times. Okay, and if you do that just by comparison, this thing you'll have to develop the intuition for over time. This is going to be lambda naught is going to be 4 lambda. Okay, moving on. The electric field of an electromagnetic wave traveling through vacuum is given by the equation E Z naught sine of kx minus, here would be some alpha t or omega t. I think that's missing here, kx minus omega t, because we have terms of omega. Kx minus omega t, the quantity that is independent of wavelength is, now again we don't need to calculate anything right off the bat. We say it's going to be k by omega. Why? Because omega by k is c, which is the speed of light. So k by omega would be 1 by c. Now it says here that it's traveling through vacuum. So I know it's going to be the speed of light, which is irrespective of the wavelength of light. So our correct answer is k by omega. The next question says that a point mass oscillates along the x-axis according to the law x is equal to x naught cos of omega t minus pi by 4 if the acceleration of the particle is written as a is equal to a cos omega t plus delta. Then we need to find what the amplitude is and what this delta is over here. So what do we know? We know that a, generally we write a is equal to minus omega square x. So the amplitude of A is going to be omega square the amplitude of x. So it's just going to be omega square x naught. So we have our options. These are our options over here, these three. So among them we need to pick out based on this delta value. Now see, here we have this negative sign, which means the phase difference between x and A is pi. There is a pi phase difference. So if my x is the argument of x is omega t minus pi by 4, then for your acceleration, you'll have the phase difference of pi. So if you add plus pi over here, you will be getting omega t plus 3 pi by 4, which means the delta that you want is 3 pi by 4. So our correct option is option A. Okay. Next question says, which of the following curves represents the variation of impedance with frequency f in the series LCR circuit? So over here, see, we want the variation of impedance. Now right off the bat, you can tell this is the correct answer. Why? Because we know that there has to be a dip in impedance. This is the point where the circuit goes into resonance, where the impedance becomes the least and the minimum value of impedance is just going to be the resistance R. As you change the frequency, the impedance drops. This is the point where it hits resonance. Then again, as you increase frequency, again the impedance goes up. Okay. Next question says, a mixture consists of two radioactive materials A1 and A2 with half-lives of 20 seconds and 10 seconds respectively. Initially, the mixture has 40 gram of A1 and 160 gram of A2. The amount of the two in the mixture will become equal after how many seconds? So over here, we know that m by m naught, so the mass remaining divided by the original mass, which let's do it for the first one. For A1, the original mass was 40 gram. Let the mass after some time be for m, and that is equal to half to the power t divided by the half-life. What is the half-life of A1? Half-life of A1 is 20 seconds, t by 20. And in the second case, you have m divided by what is the original mass of A2? It is 160 gram. M by 160 is equal to half to the power t by 10, because the half-life is 10 seconds for A2. Now we can just divide both of them. You can divide this equation by this equation because that will cancel out your m's, and your final equation would be 160 by 40, and that would be equal to 2 to the power t into 1 by 10 minus 1 by 20. Just divide them and you'll see that this is what you're eventually going to arrive at. Cancel these out so you have 4. So you have 2 square is equal to 2 to the power 1 by 10 minus 1 by 20 is going to give you 1 by 20 only, right? Because you have 2 minus 1 divided by 20. So t by 20. So t by 20 is equal to 2. So t is equal to 40 seconds. So correct option is option D, 40 seconds. Next question says, the Earth's magnetic field resembles that of a dipole at the center of the Earth. If the magnetic moment of this dipole is close to 8 into 10 to the power 22 ampere meter square, the value of Earth's magnetic field near the equator is close to. The radius of the Earth is given. We need to find it out. So because you have the Earth over here like this, and the dipole, if there's the Earth's dipole, it would be in this axis where this would be the equator, because you have the North Pole and South Pole over here. Now based on that, the equator is actually lying on the perpendicular bisector of this dipole. And we know what the magnetic field is at the perpendicular bisector of a dipole at a distance x or a distance r. That r is going to be the radius of the earth. The formula is given by B is equal to mu naught by 4 pi into m divided by r cube. Okay, so we can put in all the values. Mu naught is 4 pi into 10 to the power minus 7 divided by 4 pi just gives you 10 to the power minus 7, multiplied with the magnetic moment is provided as 8 into 10 to the power 22 divided by, we have r cube. Radius of the earth is 6.4 into 10 to the power 6, so 6.4 into 6.4 square, I write it 6.4 cube in this form, 6.4 square into 10 to the power 18. Now this 10 to the power 18 we can cancel to leave 10 to the power 4 out. This 8 we can cancel over here to give us a 0.8. Now 6.4 square, we can consider it to be 65 square. Now 65 square is 4225, or in this case it would be 42.25. Okay, 42.25 into 8. 42.25 into 8 would roughly take you around 4 into 8 would go around 33 roughly, that region. Okay, so you will arrive at the quantity where you will be having around 1 by 3 into some 10 to the power x. We don't even need to bother about that because our values are a bit different. Okay. The next question says that the Earth's magnetic field lines resemble that of dipole at the center of the Earth. If the magnetic moment of this dipole is close to 8 into 10 to the power 22 ampere meter square, value of Earth's magnetic field near the equator is close to. So we have the Earth over there, and because of its magnetic field, we can assume that there's a presumed magnet with the North Pole and the South Pole. And with regards to that magnet, the equator, any point on the equator actually represents a point on the perpendicular bisector of the magnet, because it's through the center and it's perpendicular to it, where the distance from the dipole is just the radius of the Earth RE. Now we can actually find what the magnetic field is at perpendicular bisector from a dipole. It's given by B is equal to mu naught m divided by 4 pi r cube. Now mu naught is 4 pi into 10 to the power minus 7 divided by 4 pi just leaves you 10 to the power minus 7 into m is the magnetic moment, that is given as 8 into 10 to the power 22 divided by r cube. R cube is 6.4 into 10 to the power 6, that is r. So when I write it, I'll write it as 6.4 into 6.4 square into 10 to the power 6 cube is just 10 to the power 18. So I write it in this form because I can cancel this out, giving me a 0.8. Now 6.4 is square, so I know 65 square, 6.5 square is 42.25. Okay, if you don't know how, there's a video I made separately on how to get the squares of 2-digit numbers ending with 5 easily. So I know 65 is 42.25. 42.25 roughly 40 into 0.8 is going to give me somewhere around 1 by 3. 1 by 3 or 1 by 30 into 10 to the power something. I don't even need to care about that. This is JEE. You have to be quick. 1 by 30 can only take you roughly around 0.3. Because 1 by 3, 1 by 30, 1 by 300, anything, it's going to somewhere is going to lead to either 3.33 or 33.33 something. So it's going to go with a 3 over there. So that is our correct option. Next one, total length of a sonometer wire fixed between fixed ends is 110 centimeter. 2 bridges are placed to divide the length of the wire in the ratio of 6:3:2. The tension in the wire is 400 Newton. Mass per unit length is 0.01 kg per meter. What is minimum common frequency with which 3 parts can vibrate? So over here, we know the frequency of vibration is 1 divided by 2L into root over of T divided by mu. Okay, so based on that, we ignore the L for now. We ignore the L and calculate what the rest of it is going to be. We have 1 by 2L into root over of the tension is 400 divided by mu is 0.01. So you can remove this. put 2 more zeros here because that would get you out 200. So you're essentially having 1 by L into 100. 200 divided by 2, 100 by L. That is your formula for frequency. Now, based on the 3, you would have 6:3:2. So if you put, say, here it's 110 centimeter. So each of them, if you divide, it would be 60 centimeter, 50 centimeter and 20 centimeter. Okay. So if you put the values in, you have 100 divided by, in the first one, F1, the fundamental frequency of the first case is 100 divided by 20 centimeter, which is 0.2. For the next one, F2 is equal to 100 divided by 0.3. And in the next case, you have F3 that is equal to 100 divided by 0.5. Okay, or 0.6, my bad. 100 divided by 0.6. Okay, so we need to calculate over here 2L. If you do that, you can remove these, put it 1000 up top, put 1000 up top. So then if you calculate and if you try to find what the least common multiple is, you will see it's going to be 1000 itself, because that is what you're dividing each one with, right? So your correct answer over here is going to be 1000 hertz. Let's move on to the next question. This says determine the modulation index and the carrier swing of a frequency modulated wave having a frequency deviation of 25 kilohertz and a modulating signal of 5 kilohertz. So over here, first off, we need the modulation index. Modulation index is simple. It is just delta F divided by Fm. Direct formula, delta F is 25 kilohertz divided by 5 kilohertz. I can ignore the kilo because both are in kilohertz. So your modulation index is 5. And next up, you need the carrier swing. So the carrier swing is just 2 into frequency deviation. So 2 delta F, that is equal to 2 into 25, that is 50 kilohertz. Okay, so 5 and 50, that is our answer. Next one, it says for a gas, difference between two specific heats is 5000 joule per mole. If the ratio of specific heat is 1.6, the two specific heats in joule per mole per degree Celsius is going to be. So you don't even have to think of this as Cp and Cv. Even if you take it as normal variables, it will work. Because over here, we essentially have x minus y is equal to 5000. And I also know that x by y, let's do it here itself, x by y is equal to 1.6 or x is equal to 1.6y. So if you put that in here, you will get 1.6y minus y is equal to 5000. So you have 0.6y is 5000 or y is equal to 5000 divided by 0.6. Remove this point, put a 50,000 here. This is going to be 8.33 into 10 to the power 3. Okay, 8.33 into 10 to the power 3. That is going to be the smaller one. That is going to be CV. But there are 3 options with 8.33 into 10 to the power 3. In fact, 2 options. The 8.33 into 10 to the power 3. We need to also find CP. Now CP is this X. And the CP is just this plus 5000. So this is actually 8333 plus 5000 just means 13333. So 13333 would be 1.33 into 10 to the power 4. See, this is also similar, but this is 13.3 into 10 to the power 4. This is one factor of 10 more. Okay, so this is our correct answer. Next one says a single slit diffraction pattern is formed with white light. For what wavelength of light the third secondary maximum in the diffraction pattern coincides with the second secondary maximum in the pattern for red light of wavelength 6500 Armstrong. So what do we know is the position of the secondary maximum? We know it's given by x is equal to 2n plus 1 into lambda capital D divided by 2 into small a, where a is the slit width. Okay, so in the first case, the third secondary maxima of lambda. So we have, say, x lambda is equal to, third means it is 2 into 3, 6 plus 1, 7 lambda capital D divided by 2a. This is the first case. And the second case is with the red light. In the red light is the second secondary maxima. So in the second case, which would be over here, it would be xr would be equal to 2 into 2 plus 1, so 5 lambda d divided by 2a. Now it is said that they coincide, so this is equal to that, okay? This is lambda r, by the way. If you equate both of them together, you will effectively get 7 lambda is equal to 5 lambda r, or lambda is equal to 5 by 7 into the wavelength of this is 6500 Armstrong. 6500 Armstrong. Does it go with anywhere close to 7? So this is roughly going around 9, because 9 goes with 900, because 9 would have gone with 6300. It's a bit more than that. So 9 into 5 is 45. So it would go to 4500, but a bit more than 4500. So the only option is 4642.8. Okay. Next question says, in a circuit shown below, resistances are given in ohms and batteries assumed ideal with EMF equal to 3 volt. The voltage across resistance R4 is. So it's simple. We need to find the equivalent resistance of the entire thing, find the current, and then move on from there. First step is this. R3 and R4 are in parallel with each other. So the equivalent, if you do 60 into 30, that is 1800 divided by 60 plus 30 is 90. So that is going to give you, 60 into 30, yeah. 60, am I missing out on something? Yeah, 1800 divided by 90, that is going to give you 20 ohms. So the equivalent for this part is going to be 20 ohms, right? Next thing you need is, this 20 ohm is in parallel, is in series with this. So the equivalent of this entire part is 20 plus 30, 50 ohms. Now that 50 ohms is in parallel with another 50 ohm. We know two equal resistance in parallel means their equivalent is half of the resistance. So 50 parallel means the equivalent of this entire part is 25 ohm. 25 ohm in series with this, which means the equivalent resistance of this entire part is 75 ohm. So R equivalent is 75 ohms, which means my current that I need, I is equal to V by R, that is 3 divided by 75. Cut this out, you have 25, that is equal to 0.04 amperes. Now this 0.04 amperes flows through here. As it comes to this parallel branching, you see that the distribution is going to be equal. This is going to get 0.2 amperes. This is also going to get 0.2 amperes. Why? Because the equivalent of this part is also 50. This part is also 50. That is why current divides equally. So 0.2 amperes comes in here. What is the equivalent of this part? The equivalent of this was 20 ohm. So the potential difference across these terminals is going to be 0.2 into 20 ohms, that is equal to 40 volts. And that itself is going to be the potential difference across R4. So our answer is 40 volts over here. My bad, it's going to be 4 volts. It's 0.2 into 20, so it's going to be 4 volts. Our correct option is option A. Moving on, it says copper wire, length 40 centimeter, diameter 2 millimeter, resistivity 1.7 into 10 to the power minus 8 ohm meter, forms a square frame. If a uniform magnetic field B exists in a direction perpendicular to plane of square frame and it changes at a steady rate of dB dt is equal to 0.02 Tesla per second, then the current induced in the frame is. So based on this, you know what the first thing you need is the resistance. You need the resistance, otherwise see with dB dt you can get the EMF, but to go to current you need resistance. So let's find the resistance first. R is equal to rho L by A. So rho is given to us as 1.7 into 10 to the power minus 8 into L is 40 centimeter, which is 0.4, divided by the area is just, diameter is 2 millimeters, so radius is 1 millimeter. So it's pi into 10 to the power minus 6 because pi r square, r is 10 to the power minus 3. So that is my resistance. We'll leave it as of now. We'll come back to it later. We won't calculate it yet. Next up, we need what the EMF is going to be. So the EMF is equal to d phi b dt or A into dB dt. A into dB dt. So what is the area? Since it's made into a square frame and the total length is 40 centimeter, since you're making it into a square, you can tell the side of a square is going to be 10 centimeter, 1/4 of this. So 10 centimeter area is just going to be 10 centimeters square, which is 0.1 square, that is 10 to the power minus 2 into dB dt value is provided to us as 0.02. 0.02, that is equal to 2 into 10 to the power minus 4 volts. We have got EMF. So the current that we need, I is equal to this EMF divided by the resistance, that is equal to 2 into 10 to the power minus 4 divided by the resistance, which is 1.7 into 10 to the power minus 8 into 4 into 0.4, my bad, it's 0.4, and up top we have pi into 10 to the power minus 6. So 2 into pi takes it to roughly 6, a little more than 6. And down below 1.7 into 1.4 takes it to 4 into 28. It also takes it to around 6.8. So this goes a little above 6. This goes a little above, this goes roughly around 6.3. This will go around 6.8. So 6.3 by 6.8 means it will go somewhere around 9. Okay, so our options have to be either this or this. How do I get the whether it is this or this? Now you move into the 10 to the powers because that is the only thing differentiating between them. So this 2 into pi divided by 1.7 into 0.4, this would have given me around 0.68. Okay, 1.7 into 0.4 would have been 0.68, but this would have been around 6.3. So when I cancel this, I would have got a factor of roughly 10. I'm approximating it to be 10. Okay, or rather let's keep this 9. Let's keep it 9 itself. Let's keep it 9 because we have the factor 9 here. What happens to the 10 to the powers? The 10 to the powers over here, 10 to the power minus 8, and up top we have 10 to the power minus 10, which means it's going to be 9 into 10 to the power minus 2. So this is going to be our correct option. Okay, so that's it. That finishes all our questions for the mock test today. There were quite a few interesting questions today. We'll be coming back again very soon with another mock test solutions. So subscribe to the channel if you want to stay updated and follow and get these questions that can come in your JEE. Remember, these are questions that have been coming from Sri Chaitanya as well. We have a huge legacy of 37 years producing rankers and toppers. We have got 100 percentile rankers as well in this year JEE Main January session as well. So keep following this channel. Thank you so much for watching. Catch you all in the next one.